are recording this. I'm very pleased to be offering this course and having a chance to interact with you guys from different places and from different universities. And also I'd like to thank the mechanical engineering ASME students at AUC who did an excellent job coordinating and organizing this event. Thank you guys, and hopefully you will learn something, enjoy it, and it can be overall a good experience. So I will just, and by the way, we are recording this. So these sessions that we are doing here, although they are intended to be interactive, so, we will ask you to go to a breakout room and, work on something, and I can check what are you doing and so on. But at least the major part where we all in this room, we will try as much as possible to record everything for the benefit of you in the future, and we'll make these recordings available for via a Google Drive. Is there so someone is saying that there is an issue in the voice? Okay, can someone at least confirm they hear me, even by
yes, I can hear you.
Very good, very good. Thank you so much. Excellent. So that's briefly the idea of this course. The course is really intended to get you started on MATLAB. It's kind of, not really assuming any prerequisite, but it kind of assumes that you have seen programming at some point. It's not like you are really starting programming from scratch. It's intended to be 6 sessions, and major part of them will be interactive. And the idea is just, to get you familiar, to write simple codes in MATLAB, and even to use the built-in functions available in MATLAB. And we will explain what we mean by that in the upcoming sessions. Just for those of you who don't know me, my name is Mustafa Youssef. I am an assistant professor in the mechanical engineering department at the American University in Cairo. My specialty is computer simulation of materials. So in general, I work very, very frequently with, with software codes and code development to study materials for different applications. I am originally a nuclear engineer. I graduated with a bachelor degree from Alexandria University in 2006 from nuclear engineering department. And also I had my PhD from Massachusetts Institute of Technology, from MIT, also from nuclear engineering back in 2013. So I sound to be, diverse in terms of background, mechanical, nuclear, computational materials, but, I do define myself as a computational scientist or a computational material scientist. That's a little bit about myself. I'll try to get some of you, I already know some of the names here. I'm happy to see you guys here, but if it so happens that we didn't meet before, hopefully through the breakout room, we can get in touch with everyone. I'm gonna share a screen. The course is really, to give you a background about the course, what are we gonna do? Can someone confirm that they see what we have here, even like by raising hand or something? Very good, very good. Thank you, Abdurrahman. Excellent, Islam. So basically, if you go to the slide here, the contents of this course are intended to be as follows. We want to have an idea about MATLAB as a calculator, like as a symbol calculator. We want to have an idea about basic input and outputs, basic plotting. That's probably is going to be the context of today's session. And some extent next time sessions as well. And then we will be discussing conditionals. Now we are starting to talk about programming, how to write simple codes using MATLAB. We would like to use conditionals, 2 different types of loops, the while loops and the for loops. We will touch on MATLAB functions. How do you write your own function, which is an introduction to the concept of modular programming. Very, very important in developing big projects where there are big teams and you are part of this team. You have to develop your own module. Someone else develops another module, and you guys then combine them together. And then we will move on discussing arrays. This is something of the most powerful things in MATLAB, arrays and matrices. In fact, MATLAB is coming from matrix laboratory. So matrix, which some of you might have seen in linear algebra, whether in high school or basic university mathematics courses, matrices are overwhelming in engineering. They are everywhere. And that's why MATLAB is treating everything as a matrix. And if you can transform your problem into matrix-like problem, then MATLAB can be extremely powerful in solving such problems. And then at the very end, we will discuss more advanced topics like advanced plotting. How do you, make a two-dimensional or three-dimensional plot? How do you animate something if you want to do a quick animation? Also, some built-in functions, some quite useful built-in functions. Typically, you use the built-in function if it's available. If it's not, then you need to write your own program. And finally, overview of toolboxes. And I have to say it out loud from the beginning, this course is not gonna touch in depth in any of the toolboxes. These are very specialized. For example, there is a machine learning toolbox, there is a differential equation solver toolbox, parallel programming toolbox, and so on and so forth. These are very, very specialized topics. Once you learn the basic, you can dig through these on your own, whether through texts, through YouTube, videos, and so on and so forth. But we really stop up to that level, and by that you should be ready, to use MATLAB in whatever project you are working on. So I'm gonna stop this share here, and I want to motivate something related to coding in general and programming in general. I'll share the screen one more time, but this time on a whiteboard. I tend to like whiteboards in general rather than presentations and slides because they are, more interactive. So I just want to highlight something before we get into MATLAB. We will get soon. If you are talking about programming, you want to program a code programming. There is usually two families of languages that you can work with. There is the so-called compiled languages. These are the old ones, the ones that you are probably have studied before or used in other courses like introductory computer science courses. And there are these interpreted languages, and I will explain what do we mean by each one of them in a second. So examples for compiled languages would be like C++, C itself, Fortran. If you have seen Fortran, it's kind of an old language. And in interpreted languages, you have, of course, MATLAB. That's the thing that we are going to cover. And you also have Python, one of the most famous and very competitive languages to MATLAB that are emerged in the last few years. So what is the difference between the two, and what is the advantage or disadvantage of each one of them? Compiled languages, these are the old ones, these that existed prior to interpreted languages, and they are still in existence today. In compiled languages, you need to write the whole code, compile it using a compiler. Compiler is a small software you buy it from you either buy it or get it for free from the internet that changes your code into something that the computer understands. It changes your human readable code into a code that the computer can understand and then executes it. You can execute it later on. And that requires all the code to be written at once. If you want to edit the code, you need to start from scratch again, do your edit, compile one more time, and then run your code. Interpreted languages, which are more modern, like MATLAB and Python, you don't need a compiler. It actually interprets line by line, like starts executing your code. It works on this line, it finishes it, go to the next line, it finishes it, go to the third line, executes, then finish it, okay? In the compiled, the whole code is compiled at once, prepared to be executed. And usually if there is an error in the compiled language, you will discover it at this stage while you are compiling, before you even start executing the code. In the interpreted languages, no, you execute this part of the code, and you don't know, there might be an error somewhere else. Execute the next one, execute the third one, and aha, there might be an error here, and then your program stops. Okay. Typically, interpreted languages are easier to deal with, are easier to develop a software in them, much easier. And in things like matrices and stuff like that, MATLAB could be extremely powerful. And also they have plotting utilities which do not exist in these combined languages. So if I put the pluses and minuses here, let me actually do this. If I put the advantages, easier to learn, I would say, a little bit easier to learn. Typically good with matrices, although in recent years, Fortran and C++ became as powerful in this area as well. Good with matrices. There is the plotting utility. You can plot your result, and in engineering, plotting something is extremely important. There is nothing you can do in engineering or science without actually having a plot. You need to have a plot to see your results. And this can be easily done in Python or Matlab. In C++ and C and Fortran, there is no plotting utility. After you finish your coding, you need to use another software like Excel, for example, to present your data. Here, you can plot right away with the code, and that's an advantage. So these are the advantages. The problems is typically, these are slower. So, and I have to be careful when I say slower here. Most engineering problems, like the everyday engineering problems that you solve in the industry or you solve in your undergraduate projects, you know, unless you really go to very specialized research topics or hardcore big engineering projects, the MATLAB and Python should be sufficient for you, reasonably sufficient. Like a good code is easy to develop and, you know, can execute in a couple of minutes, maybe a couple of hours, but that's totally affordable. If you want to do like extremely dense mathematical project for hardcore engineering problem or research purposes, you really have to go back to Fortran and C++. So I would say that the major advantage for these guys that the software is faster to run. It runs on the computer faster, much faster than MATLAB and Python. Okay, that's why you will find like very sophisticated computational fluid dynamics software is written either in Fortran or C++, or, you know, molecular dynamics simulation that studies material written in Fortran or C++. Okay, because these really need to run on very big computers, supercomputers, right, with thousands of processors or hundreds of processors, while most of the engineering practice can be easily done on MATLAB and Python. Code development is quick. You can visualize your data right away. Quite easy and to develop a software, although it comes with its major disadvantage, which is slightly slower running of the code. By the way, I'm gonna stop this share here now and go back to sharing my MATLAB window. And by the way, I have to mention that you are free to raise hand. The number of attendees is easy to handle here. So it's totally fine if you want to raise hand and stop me and ask something. That's actually the purpose, to have it as interactive as possible. And also, since this is a 2-hour session and it's usually difficult to, you know, focus your brain for 2 hours, we will take like 10 minutes break on the hour. So at 11, we will take 10 minutes break, and then we will get back at 11:10 to continue the remaining 50 minutes. Let's share a screen with MATLAB window open. Let me ask you first, before I do this, share, how many of you already have access to MATLAB, either, you know, the online version, or you have installed it in your laptop? Just raise hand with the, so 2, 3, 4, 5, 6, 7. Okay, so 7. That's actually half of the attendees, or 8. Yeah, that's so it seems like about a couple of you guys, they don't have the MATLAB. So if your university is AUC, then I can have a quick recipe for you to get a version of MATLAB, whether you can even do online. You don't have to install it because the installation takes a bit of time. If you are at AUC, I'm gonna copy and paste a link in the chat here that takes you to a page where you can log in with your AUC credentials, like the username and password, your email username and password, and either download MATLAB or or use it online. So let me do this for everyone in the meeting. And yeah, I just sent the link. If you go to this link, you can log in with your AUC credentials and you start having access to MATLAB online, or installed, or you can install it, but I don't recommend to do this now because it can slow down your connection or so, because you need to download stuff from the internet. It's better to use it online. That actually brings us to, and then I have to be honest here, with yet another drawback with MATLAB in particular, not with Python. Maybe I should go back to my to my whiteboard. Oh no, this is the sorry, this is the Zoom whiteboard. I want to go to the Microsoft Office whiteboard, which is this one. Abdurrahman, you have a question? Abdurrahman Salam, please. I'm assuming this is a question, not a hand from, or maybe this could be a hand when we ask it who have MATLAB. If you want to ask a question, just unmute yourself and stop me. That's totally fine. I have to highlight something here with regard to MATLAB, especially in comparison to Python. Well, first of all these compiled languages are free. Like, you can literally write any text on a text editor. You can write a C++ code or a Fortran code or a C code, and you can get any free compiler from the internet, compile your code and run it. So life is good because everything is free. With Python, that's also the case. You can, open any textbook and you might need an interpreter, but that's even free. Like, literally Google made Google notebooks. They are available online for free. And you can, and many other interpreters are available for free, and you can write a Python code and run it for free. Unfortunately, this is not the case for MATLAB. MATLAB is a commercial software. It's developed by MathWorks company, and that means that one has to pay a license for it. Some universities, they purchase a university-wide license and give access to the students, faculty, staff, and everything. Some universities have some limited MATLAB access, and you have to go to work on campus on certain computer. So for AUC, you can actually access it for free as long as you are a student from the link I just posted in the chat. I have to say that this is a major drawback in MATLAB, that you need to pay money for it. However, the capabilities it has, sometimes they bypass this. In other words, they can convince you to spend this investment and work with MATLAB. And I have to say that pretty much everything you do with MATLAB, you can do it with Python. Except with Python or with anything free, you might need to put a bit of extra work on your own, like learning on your own, or going to online forums and reading and solving one problem. And that's a skill I would like we develop throughout this course. Whenever you get stuck in something, it's good to go to an online forum, and sometimes this can actually teach you how to solve this problem. In Python, because it's a free language, you will have tons of information on the internet. In MATLAB, because it's commercial software, you will only find the forums of MathWorks are the only ones where you can find useful information. So living in a commercial software world is sometimes kind of restrictive, but still it gives you things for free. So that should be a substitute for this shortcoming. Stop share here and go back to MATLAB window. So as I said, I'm assuming many of you have access to MATLAB. If you don't have access, unfortunately, I cannot advise you on how to resolve this. And you know, I hope you can, you know, do something and get it online or get a copy from a colleague, something like that. Right now, I'm sharing the screen. I'm showing the Matlab interface. That's when you open Matlab, you have this. Basically, the menus on the top are more or less very similar to Microsoft Office, Word, or PowerPoint, or Excel. Very standard stuff. Like I mean, you can check them one by one and see what every one of them is doing. But really, most of the time, you will be working with this command window that you see here in the center. And you have control on this appearance. You can change it as you wish. On the left here, you find the files that exist in this folder. So now, for example, I am in my documents folder, and then there is this MATLAB folder, and you can change folder to any other. You can change to any other directory in your laptop. You can work on, you know, on your desktop, for example. When we start running some calculations, the details will show the history of the commands that you wrote. And, you know, the right side here is the workspace that shows the variables that you have stored in the memory of the computer. Okay, let's get started. Let's use MATLAB as a calculator. If you have it open in front of you, it would be nice to do what we are doing here, although it's very simple what we are doing, but you know, sometimes just having your hands working can speed up the learning process. So, for example, I can start calculating numbers, like calculating simple mathematical expressions. Let's say 8 times plus 11, then hit enter, and that gives me the answer. Okay, the answer is 19, and you see here it's stored. It appears here on the workspace that I have a variable that's called 19. I can even try to, you know, right click and do extra. I can edit the value from the workspace here by hitting right click and playing with it, but I don't really recommend doing this. It's better to do everything in the command window or through an M file, as we will study in a couple of minutes, hopefully. You can also use it to define some mathematical variables and do a calculation with these variables. For example, I can say that x equals 11, and I can say, you might notice something here, like when you hit enter, it's doing something a little bit annoying. When you say x equals 11, it spills out the value of x. And I have to say that this is annoying and time consuming. If you have a big code that runs and can take time, doing this can actually lower the speed of your code. What do I mean by doing this? The fact that you allow MATLAB to spill out what you have entered can slow down your code a lot. A code that can finish in a minute can, you know, spend 5 minutes because it keeps spilling out the output. So it might be wise to suppress the writing. For example, you say y equals 8. Does anyone know how do you suppress this? You can tell me right away. You don't have to raise your hand.
Maybe a semicolon.
You use a semicolon, right? You put a semicolon here, and you cannot believe how this can save time in a big code. The read and write process that the computer is doing is very time consuming. Don't underestimate this. Literally, a code that can take a minute with the semicolons, without semicolons, can take, you know, 10 minutes or 20 minutes. This is like 20 times slower. Okay, and now I can start doing algebra with these variables. For example, I can calculate x times what's going on here, x times y, so that's 88. I can even assign the result of this calculation to some variable. I can call it z. For example, z equals x times y, maybe plus 22, and I hit enter, and that gives me the value of that. By the way, if you suppress this, like for example, if I put a semicolon here and I hit enter, of course it doesn't tell me the answer, but I can always know the answer if I want. For example, it's already stored here on the right. as you can see. Okay, and even if you type Z in the command window, it's gonna give you the value stored in the Z. Okay. Here actually comes a question, and let's ask you guys if some of you already know, especially if you studied C++ or Fortran in previous courses. In C++ and in Fortran and in these compiled languages, and even in Python, I have to say, there is always this keenness on knowing, on defining variables at the beginning. You need to define a variable. Is this a real number or it's an integer? Because if it's an integer, it's going to be stored in the memory of the computer in a different way. If it's a real number, or let's use the computer sciencey way of saying it, floating number, okay, floating point number. If it's a real number, you need to define it in a different way. Does anyone know in MATLAB how these are handled? Like, do we really say that this is an integer? Do we really say that this is a real number? Is this needed? Does any one of you know this?
If I recall, I think MATLAB stores it in the form of a matrix, in a matrix. So I don't think it matters, or like it. You have to define it yourself.
That's true. That's true. Abdurrahman, you said one extra information beyond what we wanted. First of all, MATLAB doesn't distinguish between reals and integers, and you do not need to define them. In fact, whatever number you give in MATLAB, it's always considered a real number for MATLAB purposes automatically, and it is stored on 8 bytes. So I can actually make this show the memory. Yeah, the bytes. So each number of these, I just hit a right click here to see the bytes of every number here. So the variable answer has 8 bytes in the memory of the computer. X has 8 bytes, Y has 8 bytes, and so on and so forth. So as your colleague said, pretty much everything is a real number. But he also said an extra piece of information. MATLAB deals with every number as a matrix. Always, even if it's a one number, it's considered one by one matrix. Later in probably the last session of this course, we will discuss briefly matrices, and we'll tell you that MATLAB, anything it has in its memory in a number is always considered as a matrix. And you can see this, again, I'm gonna say a right click here and show the size. So the size is one by one, as your colleague said. It really recognizes every number as a one by one matrix. That's why it's extremely powerful if you can transform all your problem in matrix-like problem. Okay. I want to stop for a second here. I just want to charge my laptop. Otherwise, I will lose the connection. All right, we are all set here. So we go back. And we share screen one more time. Let's actually share everything. All right, so far we learned how to use MATLAB as a calculator. But here comes something that's pretty common to any programming language. And to some extent is the default in mathematics. And that's really the order of mathematical operations. How computer, this is very important and we have to learn it. It's a very, very important thing. And it applies whether you are doing MATLAB, you are doing Python, you are doing C++, it's pretty generic. So let's actually discuss this on the whiteboard here. Let's go down a little bit on this whiteboard. Look, there are these mathematical operations. There is the plus, there is the minus, there is the multiplication, and I hope you see what I'm writing on a whiteboard. If you don't see it, please let me know. There is the division. There is the exponentiation, like raising to a power. In fact, let me show you this on MATLAB quickly here. If I say, 8 raised to power 2, so that's actually 64. So that's 8 times 8. So exponentiation, which is given this symbol here, these are the basic mathematical operation. You need to know, and that's something you have to learn, the order of performing these operations in the memory of a computer. And I have to say again, this applies to any language. Does any one of you guys remember from basic computer science knowledge that all engineers have to know? What are the order? What has the priority? What is the top priority? And then the second priority, and then the third priority? Mustafa, do you remember this?
I think the top priority is parentheses. Then maybe the multiplication and division. I don't know about the power, but I know that multiplication and division are on the same level and they are performed from the left to the right if both exist. Also, the subtraction and addition are less in priority. No, sorry, the subtraction and summation and subtraction are on the top of multiplication and division.
Okay.
No. What?
you mix things up.
تمام يعني multiplication and division الأول وبعد كده subtraction والaddition.
Very good. Very good, Mustafa. And I hear here Muhammad also on the chat is saying something along the lines that you said, except he added also an extra piece of information that exponentiation comes first. So Mustafa and Muhammad, what you said is now correct, but let's compile the information because every one of you said a piece of the story. So number one, top priority, brackets first. Brackets first. That's the first thing. You do your brackets, okay? Number two, exponentiation. That's the second priority. You have to exponentiate everything. And then number three, as Mustafa and the colleague Muhammad also said, multiplication and division, they have the same level of priority, but they have to be performed from left to right. Okay, from left to right. And finally, and that's the least important in priority, is the plus and minus, and it's also from left to right. That's the least priority. Guys, you have to learn this. It have to stick to your memory throughout your engineering career, okay? And by the way, and that's something I should have said in the beginning, many engineers, they underestimate the programming skill. They think they can go away with a mechanical engineering degree or civil engineering degree or electrical engineering degree. They think they can go away with just without programming. I have to correct this and say that programming is an extra and important addition to your CV. If you show good programming skills in any programming language, by the way, it doesn't have to be Matlab, but at least you have the skills, at least in one language, that can boost your CV significantly and increase your chances for employability in many, many places, okay? So if you do this in Matlab, then you can transfer this in Python and so on and so forth, and you can claim in your CV, I'm good in this stuff. All right, so let's apply what you have learned here, brackets, exponentiation, multiplication, division, and plus and minus. Let's actually take an example where we need to transform it into MATLAB's syntax, okay? So the example, let's take the following example. Suppose someone is trying to calculate the following, 1 over 2 plus 3 power 2, and then 4 over 5 times 6 over 7. Someone is trying to calculate this expression. And that someone needs to be careful in terms of respecting the order of operations that we discussed above. Again, brackets comes first, exponentiation comes next, multiplication, division, and then plus and minus. Let's actually apply this in calculating stuff like that. I'm gonna bring this expression here to the right. Dealing with online stuff is becoming more difficult now that we are, alhamdulillah, we are back to face-to-face. So it's becoming a little bit more difficult. So someone calculated the answer already, 299 over 38. We will judge this answer in a second and see if it's correct. I'm gonna bring my Matlab here. You probably see that the command window is busy with a lot of things. You know, you might need to clear it for your eye in order to start working. So I'm gonna type TLC. TLC is gonna clear the screen. It will not clear the memory. As you see, ANS, X, Y, and Z are all still in the memory. They haven't been deleted. So CLC just clears the command window. If I type clear, then it clears the memory. It erases the variable. Now let's go back to our exercise. I want to write this expression, and I'm going to start writing something, and maybe you guys can, help me with this. Can I remove this a little bit? Yeah, I think this is better. So the expression here, I'm going to say the first one, 1 over, let's start first, 2 plus 3 exponent. So 1 over 2 plus 3 raised to power 2. And I claim there is a mistake here. There is an issue in what I wrote here. So question to you guys, what is this evaluating? What I wrote here is evaluating what? Mariam, what do you think?
You are evaluating half plus 3 to the power 4, not 1 over 2. The whole expression is in the denominator.
Very good, very good. So that's correct. I'm doing 1 over 2 plus 3 raised to power 2. Because, Mariam, the priority is for the exponentiation. So the exponentiation is going to be done first. The 1 divided by 2 is going to be done second. And then finally, I'm going to add them together. So, Mariam, how do I correct this? If you can suggest something. Parentheses. Very good. Brackets. Excellent. So now I can correct this. If I stop this thing, I can put parentheses here and parentheses here, and I'm good. Now I'm ensuring the following. So let's translate what we wrote. It's gonna conduct what is inside the parentheses first. And what is inside the parentheses? There is 3 raised to power 2 that has to be finished. There is, after that, there is addition to 2, and then brackets are done. I finish brackets, I finished exponentiation, and then the last thing is this division here. I need to divide the whole thing by 1. Guys, don't underestimate the importance of bracketing and doing the correct order. We have yet another answer here. We will see in a second if these answers are good. Let me clear this. Now, the next stage, I'm going to type plus 4 over 5 times 6 over 7. And I'm going to ask you guys, is this okay? Is this okay? Or do I need to put parentheses or something different? So 2 people said, actually a couple of people said no, that's not okay.
I would go with the احتياطي ان انا اعمل parentheses على 4 over 5 6 over 7.
Very good.
من باب القلق انا مش عارف بس يعني
I like this, Mustafa, being cautious. Sure, and then Muhammad also on the chat is doing this, just to be cautious. By being cautious, I'd rather put parentheses here and parentheses here, and that should be good, to be cautious, because now this is gonna be evaluated first, and then it's gonna be evaluated first, and also this bracket on the left is gonna be evaluated first. This is how the computer is gonna work. It is gonna find this bracket and this bracket and this bracket. And after this, it's gonna multiply these 2 guys similar to what's written here, and then it's going to divide 1 by this bracket here. And then finally, and only finally, it's going to add the right term to the left term. So out of being cautious, these guys suggested to put the parentheses, like Mustafa and Muhammad and the colleagues who also didn't agree with leaving it. So let's see. I'm going to calculate the answer here. I'm going to ask Matlab to calculate the answer. So what is the answer, Mr. Matlab? 0.7766. I think this might be close to an older answer here. So 9.5 is not correct, but 299 over 385, 299 over, someone suggested this. Is that a correct? It's actually a correct answer. So the colleague who suggested this one, Mustafa, is also correct. But I want to dwell on something for a second here. I want to actually go back. And by the way, learn this. MATLAB is giving you this utility. If I hit the up arrow on the keyboard, you know, the keyboard has an up arrow, down arrow, right and left. If you click the up arrow, it allows you to go to the previous command. And I'm going to go to this command here, and I can edit it. I'm going to remove the bracket here and the bracket here and the bracket here and the bracket here and try to calculate again. In fact, it was correct. It was correct. In other words, let me say something. This writing here is totally fine. And think about it. It's actually very, very correct. Why? Let's try to use colors here to see the order of doing the operations. So MATLAB is going to finish this bracket first. We said brackets goes first. And then it's going to divide 1 over this bracket. So it's going to finish, that's the next level of calculation, it's going to finish this. And then on the right term here, it's going to calculate 4 over 5. So 4 over 5. And then I'm going from left to right, right? And then multiply it by 6. So multiply it by 6. And then divide the whole thing by 7. But actually, that's fine. From algebra, you learned this in high school algebra. That's actually totally fine. This is like 6 over 7. So that's still okay. So it's going to also evaluate this term correctly, and eventually it's going to add the left term to the right term. So the previous writing without parentheses was correct. In spite of this, I strongly support what Mustafa and the other colleagues suggested in the chat, that it is safer to put parentheses, just to be safer. And also for you visually as a programmer to be able, you know, this looks fine, and you can confirm that things are going well, okay? One more comment on this before we move on to something else. The comment here is, do parentheses spend or consume time from on the computer to perform the code? Like someone says, suppose my code is very long and I became super cautious in terms of adding parentheses. Does this make my software slower? The answer is no. It's not going to make your software slower, because it's just once it's interpreted once by the interpreter, then it's going to keep it in the memory of the computer throughout your software running. And it's not going to cause any time, just maybe a couple of fractions of seconds. And that's no more than this. Okay. Any question, guys, before we move on to a next item? All right. So if no questions, the next item is MATLAB built-in functions. MATLAB comes with a lot of functions in its package that are ready for use. It can do sine, it can do cosine, it can do logarithm. If this is without 10, then this is the logarithm to base e. Log 10, that's the logarithm power 10, with base e. It can do square root, and the function for this is QRT. And I have to comment on something here. Since I wrote SQRT and sine and cosine. MATLAB is case sensitive. MATLAB is case sensitive. This is an information that's very important. MATLAB is case sensitive, meaning that capital letters gives you something different than small letters. Like literally in the memory of the computer, you can have small x equals 10 and capital X equals something else like 20 or something. Okay, so it's case sensitive, just like C++. Some programming languages, they are not case sensitive, like Fortran. So capital and small O are the same. Which means what? Which means you have to be careful in writing the names of these functions. SQRT, which is the square root function, it has to be small. Same thing for sine, cosine, log, and so on. All these functions, they have to come with the small letters. If you put capital letter, it's gonna give you a mistake. Okay, let's do something quickish before we take a 10 minutes break. And that something quickish is the following. You can always write your codes, if you wish to call them. This, what we wrote here is not really a code, it's a tiny expression. You can always write them in the command window. But this is not professional, especially if you are developing something big and it's gonna take from you time. You wanna give it to a colleague, to share it with a colleague. In that case, it's much wiser to use the so-called M file, writing in a MATLAB script or M file. Let's introduce this name here, MATLAB M file, or you can call it script. Oops, yeah, script. So what is a MATLAB script? So it is a file where you can store all the commands that you want, one after the other, and save it on your desktop. You can leave it to next day and you edit it next day. And that thing is what you see here on the left, new script. That's different from new live script. Live script is a different story. It can be helpful in educational and doing homeworks and stuff like that. But the one that we really need is just the script, the new script. And you see it pops up inside the command window or above the command window, and I can save it. I can save it on my desktop. For example, I can save this guy on my desktop, for example, and I call it, you know, anything, testing functions, because we will be testing MATLAB functions. And let me save it here. Now I can type everything in this small window or this file, and I can retrieve it. And in fact, throughout this course, any M file that we develop together, we will save to the Google Drive. And I will share with you a link for this Google Drive for the participants. I will share you this Google Drive where you can download them for future reference. I think it's a good point to take a break here. We are 10:65. Let's return back at 11:06. Let's be very, very timely. We'll get back here to 11:06. I'm going to stop the recording and see you guys in 10 minutes. Thank you.